Hello everyone. So welcome you back our lesson. This is a new part for the introduction to the quantum computing and programming the course. Okay, so this part is we want to focus on how we represent a tensor product vector. Yeah, tensor product. So actually, in practice, you want to see about the tensor flow. Yeah, tensor flow, very common in Python programming or the AI programming. So over here, we will look more about tensor products in the vector and one of the fundamental part in the quantum computing. And I hope you remember this part because this kind of a lot of math. Yeah, a lot of math. Maybe some of you it's so boring, but very important. Yeah, a fundamental the part. Okay. So actually, this part I think the most part you already learned in the high school or in the first semester. Yeah, if you are not familiar with this part, okay, no problem. So we will look how to do it. Okay. Actually, tensor. What is tensor? That is first the concept we need to clarify. When we have two vector, yeah, this is a quantum vector A, right? And we have a quantum vector vector B. So and to the quantum vector, you can represent in the in the matrix. We say this kind of matrix, or this kind of vector. You can see this the value in the matrix. And if we multiply to the vector A multiply this kind of similar like a SOR operation, but this is a multiply to vector A and vector B. So if the multiply to the quantum vector, how the value looks? Actually, it's so easy. So actually, you can see. You can multiply actually A. For I do over here to easier. Okay, A1, A2, AM. Okay, and if you multiply the two vector B1, B2, and Bn. Okay, how you multiply? You multiply this one for each this one. Okay, so you can see the first one. If you multiply h1, you will have this part. Okay. The similar, you can multiply a2, b1, a2, b2, and plus we have a2, bn, right? Yes, this one, and this one. So after we have a result for this part. Okay, so similar, you do until we have an. Yeah, we have an, b1, an, b2, an, bn. So we have this part, right? Okay, after you multiply the value for this one after, yeah, and you can match together. So this is one of you will think the total, the final value, how much? Remember, we have this is the vector includes m and multiply 1, right? We have one column with m the value. Over here we have the one column with n the value. So the total value we will have the value m. Actually, we have the A. This one is a -1. So that means the total value for each this kind of value equal to the m multiply n and one column. It's this kind of vector total, yeah, total the value. Actually, this is too many, but over here we only write the 7, the typical the value. Okay, that is very important. You multiply the matrix. Yeah, you want to multiply matrix. Okay, over here is a kind of example. If you see over here we have a vector A, the quantum vector A. We have this way of 3, right? 1, 2, 3. This guy have 3 rows, but 1 column, right? This one is B. That's, yeah. So have a same. We have 3 rows and 1 column. So after we multiply, so we have a 3. Yes, we have actually after we multiply, so we can see we have a total about the 3, 9, right? We have a 9 column. Yeah. Actually, this one is we have this 3, and this 3, right? We have a 9 column. Yeah. And multiply. This one is similar. You can multiply. Yeah. This one. Yeah. Actually, 2y. Yeah. This one is equal to this part. Yeah. So it's so easy. Actually, this part is so easy, and you can calculate. If you see the final vector value is less than 9, so that's wrong. Okay, that's wrong. To make sure, when you have you have a dimension over here, you can calculate the total value is how much. Yeah, equal to this one. The first parameter can multiply together, and you get a C. Yeah, that is equal to 9. And the similar, yeah, this one is multiply 3 vector. Actually, it's called the associative, associative property. That means when you multiply 3 vector, if you see this one, multiply this one and this one, it's equal to the multiply this one and this one. Yeah. If you see, similar, okay? That is called associative property. Okay, it doesn't matter. You can multiply first to the vector A and B first, and apply with the C vector later, or you can multiply B and C first and multiply with A later. That doesn't matter. Okay, and in practice you can simplify. Yeah, simplify this notation is A. Yeah, if you see this is different between this one, yeah, this is in my math this one is a kind of SOR, yeah, SOR, but this guy multiply, okay, yeah, multiply, yeah. So do not confuse, okay, you do not confuse about this part. This is not SOR, okay, this is a multiply. Yeah, multiply value. If you cannot see over here, A multiply with vector B and multiply C. Yeah, so multiply. Okay, multiply. So do not confuse. Yeah? And here is how we represent. Actually, this one of key point similar from previous, but this one is how to vision in the computing. Actually, different computing structure, but equivalent. What does it mean? That means A multiply with B and multiply with C equal to A multiply this B and C. Yeah, this one is equal. If you see A multiply with B and then multiply with C, right? So equal to this one. Actually, this is how to represent in the computing. Yeah, and it's one of key point. It doesn't matter you do which one first. Yeah, do this one first or do this one first. The result is similar. Okay, the result. This one is equal, yeah, equal to similar, okay? That means the different computing structure, but the same as the value, yeah, equivalent, yeah. And over here, the other thing is gonna distribute the property, distribute a property. Distributive property, over here we have a 3 vector. We have a 3 vector in different dimension. We have m, yeah, no, 4 vector. We have m, and n. So if we, we plus the 2 vector together. So I mean, only complicate from the previous one. It says you can calculate x1. Yeah, this one you can see. Yeah, you can multiply this one with x1. Yeah, okay, and x1, this x1 is equal to this part. Okay, so and this guy example, some example actually based on this guy value, you can multiply this one and multiply this one, right? And multiply this one and multiply this one. Yeah, you can multiply. So the value after you have this part, so you can move to this one. Actually, y the value to the 0 could be to this value. We will look later. Okay, we will look more detail in a later lesson. Yeah, over here you only know. Okay, we transfer to this one. Yeah, to make sure you got it. Yeah, this one. Yeah, I would say we will look more introduce later. Yeah, to make sure. So this guy value is called the linear combination. Yeah, linear combination. Yeah, that is one of term. I hope you remember because it help you to calculate and help you to use computing in a quantum circuit in the future. Okay, the key point in this part we have. I hope you can remember about the calculate about the linear. Yeah, linear combination. Like you can have A, this one A, B, C equal to the A and B. Okay, this one. So actually, this guy formula doesn't matter how you calculate the value, but when you calculate a different structure, they have the same value. Yeah. Okay. So that is it's called the linear combination, and we already introduced about linear combination, and we introduced about how the tensor products in the vector space look. Okay. So we'll look more the next lesson, okay, to represent the quantum vector. Yeah. Okay. Thank you, everyone.